This is Jack Jackson back again with another video talking about circular trigonometric functions. And here's a type of problem that you might encounter in the homework, typical kind of problem you'd see in the trig class. So I've got 4 different problems here, and we're going to try to work through these. Compute the values of the 6 trigonometric functions in each of the following cases. So the first problem is, we know that the sine of t is 4/7 and the cosine of t is positive. Okay, so let's see what this means. Now remember, sine of t, sine, remember, is y over r. So in this case, we know y. We can think of that as 4/7. So we can think of the y as being the 4 and the r as 7. Okay? So let's take a look at that, and I can go back to my sketch and illustrate this as well. So in this one, we know y and r, so I'm going to click on this thing here. So the first thing we're going to do, as you can see worked out here, well, I need to put the numbers in. What do I have for y and r? Y is 4 and r is 7. Okay. 4 and r is 7. So I have the situation drawn here, as you can see in the picture. Over here, if I click on this, you can read this now, hopefully. So we can use the Pythagorean Theorem, first of all, to solve for x. So if we know x, y, and r, if we know any two, we can find the third one. This is going to allow us to solve for x. So we know x squared plus y squared equals r squared, so x is plus or minus the square root of r squared minus y squared. So 7 squared is 49, 4 squared is 16, 49 minus 16 is 33, so x is the square root of 33. So this says that x is plus or minus the square root of 33. There's either positive or negative. Now cosine of t, remember, is x over r. Remember, r is positive. So if cosine is positive, this tells us that the x is positive, so that means we keep the positive one here, x equals the square root of 33. So now we know x, y, and r. We can figure out all of the trig functions. Okay, so in this case x was positive, so I can click on this button right here, and this part right here shows me all of the trig functions that I have here. So cosine is x over r, so it's actually it's actually 4 over the square root of, x. X is square root of 33. So it's actually the square root of 33 over 7 is cosine. And the 5.7 whatever is approximately what the square root of 33 is. And if you work that out approximately on the calculator, it's about 0.82. So the drawing that we're looking at to see where the angle is that we're talking about, y is 4 means it's somewhere on this horizontal line here, and if it's a radius of 7, the point is on this circle. Notice there are 2 points there, and we have to know whether x is positive or negative. Turns out x is positive, so we're talking about this point right here in the first quadrant. So this is the angle right here that we're dealing with. In fact, we can figure out what the angle here is just in a minute. Okay? Now, actually, depending on either one of these, whether x is positive or negative, we have this same reference triangle, or congruent reference triangle, with the same reference angle here as we have here, which is, remember, the reference angle is always an acute angle. If you have an angle that's not one of the axial angles or quadrantal angles. Okay, and so what do we know? We know the y and the r. So if we take the absolute value of the y over r, that's going to be the inverse sine. That is going to be the sine of this angle here. So it's the inverse sine of 4 over 7, absolute value 4 over 7, which is approximately 0.60825 radians. And in fact, that actually is one of the possible angles, since it actually is in the first quadrant. So all your angles are that angle plus or minus plus 2 times n times pi, where n is some integer. And of course, that's an approximation there for that radian measure. So any angle, rotational angle, that ends in this same place as this angle right here, that's going to be a possibility, which are just add or subtract multiples of 2 pi to integer multiples of 2 pi to that amount of radians, and you get the total radians there. Now let's continue on. If we know the x and the y and the r, which we have established now, x and y and r right here, we can just use that to find all the trig functions. So going back, cosine is just x over r, so that's the square root of 33 over 7 exactly, or approximately 0.82065. Y over r is going to be 4 over 7. That's what, and that's 0.571428. The whole thing repeats actually. Tangent is y over x, so that's 4 over square root 33 exactly, or approximately 0.69631. The secant is the reciprocal of cosine, so it's r over x, so that's going to be 7 over the square root of 33, approximately 1.21854. Cosecant is the reciprocal of sine, so it's going to be r over y, so that's going to be 7 over 4, or exactly 1.75. Cotangent is x over y, so that's going to be square root of 33 over 4, or approximately 1.43614. Okay, let's do another one. See if you can do this one now on your own. Cosine of t is negative 3/8, and tangent of t is a negative number. Press pause now. Okay, now that we're back, remember cosine is x over r, so, and r is always positive, so let r be the denominator here. So if r is 8, then x is negative 3. Of course, we could also have other points that we could use. We could let r be, we could double r, we would also double x. So you can make these things go up and down some, but the easiest way to do it is just let the denominator be r, and the numerator be x. And remember, if there's any negative sign, it has to go on the x or y, not on the r. R is always positive. Okay? The tangent is negative. That tells us, this part right here tells us that it's in quadrant negative. Quadrant 2 or 4. Quadrant 2 or 4 is where tangent is negative. Okay, so x is negative. That eliminates quadrant 4, so it's in quadrant 2, which says that y is positive. So when we get our choice of y, we're going to choose a positive y. Okay, so let's see what we have. This time we know x and r, and we want to find y. So let's hide this. Let's hide that, and we know x and r. So in this case, x was negative 3 and r is 8. So you type in here 8 for r and negative 3, and now we'll get a picture here. So notice we have x is negative 3, that means you're on this vertical line here. R is 8, so we're on this circle. That gives you 2 possible values here, one in the second quadrant, one in the third quadrant, but we wanted the tangent to be negative, so it has to be in the one in quadrant 2. So we're talking about the point right up here, and so we're talking about an angle that somehow rotates around to that point. Okay, so let's go through here. What about the y? Well, y is plus or minus the square root of r squared minus x squared, so that's the square root of 8 squared minus 3 squared. So 8 squared is 64, 3 squared is 9, 64 minus 9 is 55, so y is the square root of 55, or approximately 7.41620. But is y positive or negative? Well, remember, we're in this quadrant, so y is positive, so it's actually the positive square root of 55. Okay? Now, what about the angle? What is this angle, say, this angle here? Well, we can first find this reference angle from our triangle, and if we take the x, we're given the x and the r, so x over r in this triangle is the cosine. Well, it's not really the x, it's the absolute value of that x, 3, over the 8. So you do the inverse cosine of 3/8, and you get approximately 1.18640 radians. Now that would be for this angle right here, right there. That angle is a reference angle. That's the one that's the a little bit over 1 radian. Now, so what do we have here? We have actually pi minus that. Let's look down here at the bottom now. So the angle is pi minus that, which is 1.95519 radians. Okay? Or, we can also say plus 2n pi for any integer n. So we can also, that's not the only angle we can get it. So the angle of 1.955 radians is the angle, smallest positive one that rotates from 0, rotates around this way. Oops. Starts over here, rotates around, and ends right there at this point here. But we can also rotate around an extra full circle in either direction and get there too. For example, we can just rotate around this way in the negative direction. That would be 1.95519 approximately radians minus 2 pi. Or we can rotate around many, many times. Now, what are the values of the trig functions now? Okay, let's take a look at that. Well, once we have x, y, and r, we're in business. So y is positive square root of 55. So y is the square root of 55. And so now we have x, y, and r. It's pretty easy to set up our trig ratios based on that x, y, and r. And every time you're doing these, I encourage you to write down these formulas because you're going to memorize the definitions a little bit better as you do this. So cosine is x over r, so that's negative 3 over 8. Exactly negative 3/8 or negative 0.375. Secant's the reciprocal of that, so it's r over x, or 8 over negative 3, or negative 2.6 with the 6 repeating. Sine is y over r. Now I've got 7.41620, but that's approximately the square what you get when you do the square root of 55. So exact value would be square root of 55 over 8. And that works out to be approximately 0.92702. The cosecant then is r is 8 and y is again the square root of 55. So this would be 8 over the square root of 55, or approximately 1.07872. I may switch this up a bit so it'll actually show that as the square root of 55. Tangent is y over x, so y again is square root of 55 and x is negative 3, so it's negative square root of 55 over 3, or approximately negative 2.47207. Cotangent is x over y, so that's negative 3 over square root of 55. Okay, let's try another one. Your turn. We know the cosecant is negative 8/5 and the cotangent is positive. Work this one out. Press pause now. Okay? Cosecant, remember, is the reciprocal of sine. So that's r over y. So one way we could do this is to let r be the 8. Remember, the r's got to be positive. And the y could be negative 5. Cotangent is positive. Cotangent is positive. That's either quadrant 1 or 3. Okay? But y is negative, so that must mean we're in quadrant 3, which means x is negative. So when we get our choice of x's, we'll get that. Let me just do it here by hand. X will be the square root of r squared minus y squared, plus or minus. Okay? But we want the, it turns out we want the minus one because of this. So it's negative square root of 8 squared minus negative 5 squared. No parentheses there. So you get 25, 64. So 64 minus 25, what is that? 939, I think. Okay, so negative square root of 39 is x. So there's x, and here's r and y, and so we can figure out everything on our trig functions for that. So we were given r and y to begin with. R is 8, y is negative 5. So r is 8, y is negative 5. So looking at the picture, it's one of these guys down here. It turns out the one we needed because of the, what was it, cotangent was negative, cotangent was positive. We need something quadrant 1 or 3. 1's not a possibility. Looks like 3 is our only choice. So here's our reference triangle right here, down here in the third quadrant. Okay, so square root of 39, and it is the negative one. So we're going to look at this version right here, where x is negative. So, square root of 39, negative square root of 39 over 8 is the cosine, approximately this much right here. So r over x is secant, so that's going to be 8 over negative square root of 39. R over y is cosecant, so that's 8 over negative 5, negative 1.6 exactly. Y over r is sine, so that's negative 5 over 8, so it reduces, in decimal form, that's negative 0.625. Y over x is tangent, so that's negative 5 over a negative square root of 39. So the two negatives cancel, so it's 5 over square root of 39 is the exact value, or approximately 0.80064. Cotangent is positive ultimately, like we see here, which was one of our requirements. X is negative square root of 39, it's over negative 5, which is y. Two negatives cancel out, so the exact value for cotangent is square root 39 over 5, approximately 1.249. What about the angle? Okay, a couple different ways we can do it. First of all, let's just find this reference angle. Okay, and we can take the absolute value of the y over the r, so 5 over 8 is the sine of this acute angle. So the acute angle that we're looking for is the inverse sine of 5/8, which is 0.67513 radians. That would be this acute angle right here. Okay, so one way we get there is add pi to that. And if we add pi to that, we get approximately 3.81627. And of course, if we add or subtract any integer multiple of 2 pi to that 3.81672, we get another angle that's coterminal. Okay, one more for you to try. Okay, try number 4. Work it out now and then come back to the video after you've done that. I really encourage you to do these on your own and then check your work rather than just watch the video. So press pause now. Okay, you're back. Your cotangent is reciprocal of tangent, so it's x over y. So we can let x be 5 and y be 7. R then is the square root of x squared plus y squared. So r is the square root of 5 squared plus 7 squared. That's 25 plus 49. Let's see, 74. So square root of 74 is r. Notice this is a quadrant. 1 well, it's plus or minus this. Okay, so which is it, plus or minus? Well, this is quadrant, cotangent is positive, so that tells you it's quadrant 1 or 3. But sine is negative, that tells you y is negative, so it's either quadrant 3 or 4. We'll put these together, the only overlap is quadrant 3. So we get a negative y. Okay, but we also get a negative x. Okay, so actually we're going to need to make both of these negative, and the r, actually r is always positive. but in this case we needed to make x and y negative. So x is negative 7, y is negative 7, r is the square root of 74. Okay? So this one we're given x and y. So once we worked on it a little bit, we figured out they're both negative. X is negative 7, negative 5, and y is negative 7. And there we have it. And here is our reference triangle right there. So it's a third quadrant one. Okay? And here are our answers. Okay? So again, there's a square root of 74. Is that what I came up with? Yep. Square root of 74 for the approximately 8.6 something. That's what we came up with for the what is that? For the radius r. Okay, so the equation of the circle that we see there is x squared plus y squared equals r squared. So it's x squared plus y squared equals 74. And the trig functions are x over r, so it's negative 5 over square root of 74, approximately here. So then square root of 74 over negative 5 is secant. Y over r is sine, so it's negative 7 over square root of 74, exactly, or approximately this. Cosecant is r over y, so it's square root of 74 over negative 7, approximately negative 1.223. Tangent of y of the angle t is y over x, which is negative 7 over negative 5. That reduces to 7/5, or 1.4 exactly. And the reciprocal of that is 5/7, or 0.7142 9, rounded off. Notice that the angle for the reference angle, not the angle we have here, but the angle on this side in here, that's the reference angle. And that reference angle we can get by taking the y over the x, absolute value of everything, and then do an inverse tangent. That will give you that acute angle. So the inverse tangent of 7/5 is 0.95055 radians. Now, what do we have for our angle here is actually going to be, well, if you do pi minus that much, you would get 2.19105 radians, but it's in the negative direction. So that's it. Okay, so this shows you how we can use this sketch to do some examples. It also shows you how you can do some of these things by hand. And hopefully that'll give you some examples of problems that we can do, typical kind of problems that we can do based on understanding, seeing if we understand circular trigonometric functions.